Leisure tourism is a very complex area as it involves sensorial experiences and emotions, being subject to many variables. This complexity is aggravated when groups of tourists are involved, such as excursions of casual groups of tourists, increasing the heterogeneity and conflicting preferences, which is not simplified by the information overload found on the internet. Where to go? Which tourist attractions are more attractive for a certain group of tourists? Group recommender system for tourism came to tackle that complexity, helping the choice of destination, accommodations, points of interest to visit, and so on. However, the group recommender systems available are limited, and the complexity associated to group recommendations still needs strategies to mitigate several problems, such as group's heterogeneity and conflicting preferences, the emotional contagion phenomenon, how to provide first recommendations without using the interaction with the system, negotiation of feedback, and group members' needs and concerns while providing recommendations to satisfy all members at once. In this demonstration, we present Group Planner, a group recommender system for tourism prototype. Group Planner is intended to help occasional groups of tourists choose which points of interest to visit at a certain destination, using their personality as core feature to solve their issues, by diminishing the information needed to build the tourist's initial profile just by using their personality, disabilities, and fears. Dynamically aggregating new tourists on demand into a cluster of tourists with similar personalities, dividing the main excursion group into subgroups with similar personalities and therefore preferences, less heterogeneity, and less conflicting preferences. Providing the initial recommendation list just by knowing the tourist's personality while caring for their needs and sense of belonging to the group. And allowing the subgroup members to anonymously rate the recommended point, diminishing the manipulation of the other members to reach a final consensus without need of a long and tedious negotiation process. So why use personality? In previous works, it was found that the tourist attraction's preference can be predicted by the 5 dimensions of personality. For example, individuals with high extroversion and low consciousness tend to enjoy their own activities. In the prediction, each tourist obtains a preference score for each tourism category, which we use in our prototype to categorize the tourists into a certain cluster. We'll talk about the clusters later. The same prediction applies to travel-related preferences and concerns, where it was found they are also influenced by personality. For instance, extroverted, agreeable, and open to experience individuals like to visit unique and exotic places. Due to the complexity associated to groups of tourists, several strategies are being proposed to improve recommendations, like preference negotiation, emotions, pairwise preferences, location-based social networks, or even multi-agent systems. Hoping to solve some of the opinion issues, in this demonstration we introduce 4 novelties implemented in a group recommender system for tourist prototype. A multi-agent microservice, which results from the remarkable similarity between multi-agent systems and microservices. The tourist's personality is used to predict that tourist attraction preference and travel-related preferences and concerns in order to provide initial point recommendations. This tackles the cold start problem, as the group members are automatically assigned to the preliminary preference score in categories of tourism and travel-related preferences and concerns immediately after registry, and the recommended list of points can be generated only based on that knowledge. A novel strategy for aggregating preferences that aggregates tourists with similar personalities using dynamic clustering. That is, based on the personality scores of each tourist, the MEMS determines in real time how similar a tourist is to another, so clusters of similar tourists can be created. This per-clustering phase will help form subgroups of tourists with similar interests when requesting recommendation, as we believe it will be more beneficial than to stay in the main heterogeneous group. Application of the a priori algorithm for each subgroup, to find rules in the corresponding clusters according to the tourist profile and travel history, and create a list of points to include or exclude in the recommendation list for the respective subgroup. Group Planner is composed of 5 microservices published in a Microsoft Azure server, implemented using .NET, C# and the Actors Mass multi-agent framework. When a tourist registers the application, she needs to fill mandatory information related to demography, disabilities, and fears or phobias. To receive automatic recommendations of points of interest, the tourist needs to fill the Big 5 inventory to assess their personality, which is then used by the multi-agent microservice to predict their preference in the proposed 11 categories of tourism and travel-related preferences and concerns. The scores obtained can then be consulted in the user's profile. The application allows to save the visited points of interest, rate them, and define if they are to be revisited. The tourist is registered, authenticated, and authorized in the system through an API gateway using DAS.NET Core Identity and JSON Web Tokens. The gateway was implemented using the DAS.NET Core framework, acting as a single entry point into the system, forcing all the HTTP client's requests to pass through it. The tourist profile is compiled to a JSON sent via HTTPS post to the user management microservice and multi-agent microservice, which creates an agent model with a tourist profile in the MEMS environment. If the tourist is the first user registering the application, a cluster based on its personality score is created, becoming the centroid. Otherwise, a similarity to the center of the existing cluster is calculated using the normalized Euclidean distance and is added to the most similar one, or to a new cluster if all similarities are below 80%. To avoid processing delays, the cluster centroid is updated every 24 hours, but can be configured. This dynamic clustering is an innovative approach, used to the best of our knowledge for the first time in group recommender systems, accurately assigning tourists to clusters of other similar tourists as they register in the application. The application allows to create excursion groups, define dates and destination, and add registered members. When a tourist creates an excursion group, becomes a group owner, an adjacent containing the group member's profile, demographic data, personality, disabilities, fears, and if available, the rated by history, is sent via HTTPS post to the Multi-Agent Microservice, which then creates a travel agent representing the group. The group owner can then request recommendations for the excursion group. The application has a chat dedicated to the main excursion group, where the members can talk to each other if necessary. In this case, after requesting the recommendations, the excursion group was divided into 4 subgroups of members with similar personalities, which is explained next. When the group owner requests a group recommendation, an HTTPS request is sent to the group's travel agent. If at least 3 agents belong to the same cluster, a subgroup with the agents belonging to that cluster is created, as well as a subgroup travel agent responsible for the subgroup's agent's communication, along with the justification for each subgroup form. For instance, this subgroup likes nightlife, adrenaline, and wild nature activities. In case there are agents that would create a subgroup of only 1 or 2 members, their personality, or average personality in the case of 2 members, is compared to the already formed subgroup centroid, and they are included in the most similar one. It is important to refer that neither subgroup centroid nor the originating cluster centroid are updated at this stage. This guarantees that the centroids only consider most similar tourists and consequently with similar tourist preferences, and that they are not damaged by the posteriorly added tourist personality. If at least 2 subgroups could not be formed, the main group remains intact, and the recommendations are considered for the full group. Each subgroup agent then asks the subgroup members for their travel history and searches for positive and negative rules in the respective cluster, applying the a priori algorithm with at least a 90% confidence interval to the tourist profile and ratings. The rating interest for a visited boy, if available, comes from previous recommendations the tourist rated as interesting to visit or not, or from the average rating of the other tourists in the same cluster if the tourist has not rated that boy yet. The rules found are added to a list of rules for each cluster, which will help in the recommendation process. This algorithm is programmed to run as a job during late night once a day to update the cluster's rules. If 50% or more tourists in a subgroup match a certain rule for a boy, that boy is added to an exclusion or inclusion list depending if it is a negative or positive rule. Negatively rated boy and positively rated but the majority does not want to visit again go to the subgroup's exclusion list. Positively rated boy and majority never visited go to the inclusion list, otherwise go to the subgroup's exclusion list. This helps increase the recommendation diversity. This means that, although a tourist says he wants to revisit a certain boy, that boy should only be recommended if the majority never visited it, and the never visited boy have been recommended first. To avoid unsuitable recommendations, the subgroup agents only use the ratings given by the subgroup's members that originate from the same cluster. After creating the subgroups, the travel agent sends a JSON via HTTPS post to the recommendation engine microservice, containing the subgroup's members' profile and their exclusion and inclusion lists. The recommendation engine then searches for the 10 best matching POI for each subgroup in a POI ontology, persisted in a repository with POI retrieved from TripAdvisor API. Using the data received, the POI are assigned to each subgroup's 3 top preferred tourism categories. The travel-related preferences and concerns are used to further refine the recommendations and better match the POI to each subgroup. It is also in this process that the tourist disabilities and fears are considered. To recommend a greater diversity of tourism categories, the relative importance of a tourism category score is used to decide how many POI will be recommended for that category. This means different number of POI can be recommended, and that the order of the recommended categories is important. The recommendation engine then answers to the requesting travel agent with a JSON containing the list of POI suggested for each subgroup, along with the justification for each recommended POI. The travel agent then sends the JSON to the group planner application, which creates the suggested subgroups and presents them on each subgroup's interface along with their respective POI recommendation lists. At this point, each subgroup's members can obtain more information on suggested POI, individually rate them, and chat with the respective subgroup members if necessary. To mitigate the emotional contagion phenomenon, only when all members have rated the recommended POI, the subgroup's average rating for each POI is displayed in the recommendation list. The group owner is responsible for asking the subgroups if they want to keep their recommendations or ask for new ones. If so, all points of interest A rated below 3 will be replaced by new POI. And that's it. You can scan the QR code to download and install the prototype. Hope you have enjoyed. Thank you for watching.